Okay, hi, so welcome to this video on electric circuits. So this is going to be the first video in a series where we look at different electric circuits, so how we calculate different things from electric circuit diagrams, what an actual electric circuit is, and the different components which make them up. But first of all, what we're going to talk about is exactly what an electric circuit really is. Now, if you haven't seen my last video on static electricity, please have a look at that first, because it just gives you an idea of what is moving and what is creating charge. But in an electric circuit, you have electrons moving, right? We discussed that electrons are negatively charged, and in an electric circuit, and let's just draw something really quick here. Let's say this is an electric circuit, okay? This here, this symbol, is for a cell, and a cell basically is where you're going to be getting your energy from, right? So a battery is more than one cell put together. We'll have a look at that in a second, but a cell basically is supplying your energy, right? And it's allowing this circuit to be formed. And basically electrons just travel through this wire, okay, etc. And so they keep going around, and electrons are negatively charged, okay? So, on your battery, you know you have a negative terminal and a positive terminal. The electrons move from the negative to the positive, and it goes round like that in a circuit. Those electrons actually carry energy, right? That energy is supplied by the power source, in this case the cell, could be a battery, could be your mains electricity, right? And that energy can then be used by other things to do something, right? To do some sort of work. For example, to light up a bulb. Right? If the electrons have enough energy, then they allow the light bulb to be switched on, right? And so that's basically what an electric circuit is. Okay, it's electrons moving from one end of your power supply to the other through the circuit and causing something to happen. All right, so what we're going to have a look at is the actual things which can make up a circuit, right? You need to know various different symbols and what they actually do. So if we go down here, we have a nice list. Okie doke. So first of all, we have our switch. Now what a switch does is it allows you to break a circuit. So if, let's go back up to our wire. If on any point here, okay, let's say we had a switch and that was open. Okay, if that was open, then the wire is not complete. Right, because this in the middle wouldn't exist, and then the wire is not complete, and the electrons can't get from one side of the circuit to the other, and the circuit is completely broken. And so that's why when a switch is open, the electrons can't actually flow through the circuit. Okay, and that's it. So a switch allows us to turn on or turn off our circuit because it provides a break. Okay, and obviously you have your open and closed symbols. When the switch is closed, then the circuit can do its thing. And when it's open, it cannot. All right, next you have a cell, and we already discussed that a cell is the power supply. Okay, so I'll put power supply. Right, it's not the only type of power supply. Obviously, you have mains electricity at home, but the cell is a simple unit of power supply. Right, now a battery is just a term for more than one cell combined. Right, so a cell produces what we call a voltage. Okay, we'll have a look at that later. It's basically how much energy does it provide, right? But a cell normally can't provide the amount of energy that we want, and so we combine more than one cells, and then we call it a battery. All right, and so a diode only allows current to flow in one direction, right? And that sounds a bit strange at the moment, but if we go back up here, you see that electrons, okay, are flowing in one direction through our circuit. However, from the mains electricity, okay, when you plug something in at home, we have what we call alternating current, which means that they keep changing the direction that they're traveling around the circuit. Okay, the diode is something which only allows them to go one way. So when they change direction and choose to go the other way, the diode stops that from happening and only allows current to flow in one direction through a circuit. All right, so that's what a diode does. So a resistor, okay, a resistor. It provides resistance, okay, so it provides resistance. Okay, and what does that mean? All of these terms, by the way, and all of these components we're going to have a look at in more detail in later videos. But You need to be aware of all of these things and what they look like. But what resistance is it resists the electrons flowing. Okay, so if you have more resistance, then the electrons are going to struggle to flow through the circuit, so they're going to go slower. Okay, because the electrons are traveling at a certain speed. That speed is what we actually call the current, right? It's the rate of which electrons are flowing through the circuit, right? That's what the current is. So when you hear about current in a circuit, it's basically how quickly are those electrons going through the circuit, right? A resistance will reduce the current. Okay, if you increase resistance, then the current goes down because you're sort of pushing against the electrons, so you're making it harder for the electrons to travel through the circuit. All right, and so a resistor, the job of a resistor is just to provide resistance, and a variable resistor is exactly the same. It provides resistance, but the word variable means that we can change its resistance, so we can make it less. We can make it provide, less or more resistance based on what we need at that particular time. Okay, you then have a lamp, and that's pretty self-explanatory. It's a bulb that's going to light up. Okay, so a lamp or a bulb. Normally this is a filament bulb, so sort of the old school type of bulbs. A lot of bulbs now are LEDs, right, which we see down here. Okay, but this is the sort of traditional symbol for a bulb. You have a fuse. Okay, a fuse. This is a safety feature. Okay. So it's a safety device. Okay, and basically it will break if something goes wrong. So we have a fuse so that if something goes wrong, we can break the circuit and stop anything from becoming dangerous. Right? It's almost like a switch, but it only stops the current flowing when something goes wrong. Okay, we then have voltmeters and ammeters, which we're going to look at in the next video. They are devices we use to measure both the voltage, obviously with the voltmeter, and an ammeter is used to measure the current, right? So I'm going to say voltmeter measures voltage, and an ammeter measures current. Okay, I'm going to go in a different order and go down to here, which is the LED. And an LED, remember we said a diode only allows current to move in one direction. An LED, so that stands for light emitting diode. Okay, I'll write that here. And sorry for the handwriting. Light emitting diode. Okay, it's still a diode, so it only allows current to flow in one direction. However, when current does flow through it, it gives out light. Okay, and that's why we have LED bulbs, and now obviously we have LED TVs and stuff like that as well. But it is based on the same technology, so it gives out light when current flows through it in that particular direction. It doesn't allow current to through it in another direction. All right. Finally, we have Ldr and Thermistor. Okay, Ldr stands for light dependent resistor, and this is really bad writing. Sorry about this. Resistor. There we go. And just like we've seen over here with the resistor and the variable resistor, a thermistor, well, therm comes from the word thermal, and it varies with the temperature. Basically, the resistance, when you increase the temperature, the resistance through a thermistor will go down. Whereas in general, okay, the physics is that if you increase temperature, resistance of anything goes up. And so thermistor is kind of the opposite of that, and that's why you give it the name thermistor. And light-dependent resistor means depending on how much light shines onto your device, the resistance through the current circuit that you have set up is going to change. Okay, so the resistance in that circuit will change based on whether you're shining light on that device.